Hello, welcome to another episode of Xa Talk Show. We are going to do Advent of Code, Day 6. Okay, Advent of Code, Day 6. So let's go to today's talk show. Let's begin it. Podcast talk show, Advent of Code, Day 6. So this is today. Let's begin. Wolfram language, pop it out, refresh. Yeah. Oh yeah. So my keyboard this is Kinesis 360, the wired version. Okay, I have a review on my website. Just search for Xadi keyboard, Kinesis 360, and this is Ultimate Hacking Keyboard. Switch back so you can see. So okay, so let's begin coding actually. So Advent of Code, today's 2014. There. Okay, let's see the problem. If you are here, say hi. Okay, hello, number 6. Let's see, day 6, Advent of Code, day 6. Magnify. Let's see, weird arrangement of the problems. You know, so this is a mini logic puzzle. Figure out how do they arrange this Advent of Code day numbers. You see, 1, 2, 3, then 4 comes here, 5 comes here. How did they, you know, what is the logic behind it? That's a mini puzzle, okay? But anyway, we're gonna do day 6. I have not read the problems yet, so I will try to finish it in at least part 1, okay? The ferry quickly brings you across island. After, this is day 6, yes, wait for it. After asking around, you discover that there's indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and a small island where ferry Are you trying to, as you try to figure out what to do next, you noticed a poster on a wall. Drop AOC on day 6. On what day you will drop it? What are you talking about? Okay, trolls, go away. You know, you type of 4chan type of people, that doesn't do anything to me. So so wait. So let's double check, video check, audio check, and yeah, I'm good to go. So back to day 6. So as you try to figure out what to do next, you notice the poster on a wall near the ferry dock. Boat races open to public. Grand prize is an all-expensive paid trip to desert island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can. And you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. Okay, so appears to be many races. Okay. You have to make sure you go farther in each race than the current record holder. So there seems to be multiple number of them, and in each one, is there one record holder for all of them, or each race have a different record holder? You don't know. I don't know. So the organizer brings you over to the Can you see it? Yeah. So the organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. they are actually toy boats, each with a big button on top, just like Advent of Code, toy problems. Holding down the button charges the boat, okay? And releasing the button allows the boat to move. Oh, okay. Charge and move, charge, stop, release, move. So it's like the opposite of the gas pedal. Boats move faster if their buttons was held longer, but time spent holding the button counts against the total race time. What? You can only hold the button at the start of the race and boat won't move until the button is released. Okay, you can only do it once. So you press to charge and release to go. And you can only do this one time in the beginning, okay? For example, time 7, 15, 30, distance 9, 40, 200. This document describes 3 races, okay? The first race lasts 7 milliseconds. The record distance in this race is 9 millimeters. What? Okay, the first race lasts 7, so the first row is how long is the race. The second row is the distance, the record in distance, okay? Okay, the second race lasts 15 milliseconds, correct? The record distance in this race is 40 millimeters, okay? The third race is lasts 30 milliseconds. The record distance in this race is 200 millimeters, okay? Your toy boat has a starting speed of 0 millimeters per millisecond. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per millisecond. Jesus. So when you hold down the button, the duration will increase your boat speed. Increases by 1 millimeter per millisecond. So increases by, so you hold it for 1 unit of time, your boat speed increases 1 unit of distance, something. So, because the first race lasts 7 milliseconds, you only have a few options. Okay, so the last something second means that's the duration of the race, that's given. So one of the race is 7 unit of time. Another one is 15 units of time. So this is a limited amount of time for the entire race. During this time, you can kind of decide how long you're gonna hold the button, something like that. Okay, so because the first race lasts 7 milliseconds, you only have a few options. Don't hold the button at all. That is, hold it for 0 milliseconds. At the start of the race, the boat won't move. It will have traveled 0 millimeters by the end of the race. Okay, you have to charge it. You have to press the button at least once, otherwise you go nowhere. Hold the button for 1 millisecond at the start of the race, then the boat will travel at the speed of 1 millisecond per millisecond, 1 millimeter per millisecond for 6 milliseconds, okay? Right, so you have a limited period of time, limited period of time. Then during this time, you have kind of decide how long you're gonna hold the buttons. So this is kind of like race condition. Race condition is a computer programming jargon, but this is not exactly a race condition, but literally it is a race condition. So given a set of time, fixed amount of time, you have to decide how long you're gonna hold the button, and So then the rest of the time, your boat is gonna move according to how long you held the button. So the problem is a maximization problem or optimization problem. So essentially, you want to determine how long you're gonna hold. You want to find a point, how long you're gonna hold it, so the boat moves the maximal distance, something like that. Okay, option, hold the button for 3 something. After it's remaining for something travel time, the boat will have gone 12 millimeters. Okay, so let's see, you hold it for 3 milliseconds. That means your speed is 3 units per second. Let's drop the milli. Fuck the advent of code. Okay, let's just drop the milliseconds and millimeters. Fuck. Let's just say, so you hold it for 3 seconds, then that means your speed will be 3 meters per second. Then if you hold for 3 seconds, you have 4 more remaining seconds. So 4 times 3, your speed is 12, your distance moved, okay? Then hold for 4 milliseconds and something. So if you hold for 4, right, then your speed is 4 meters per second. But now your time for the boat to move is 3. 7 minus 4 equals to 3. So 3 times your speed, which is 4. 4 times 3 is 12. So, okay, so we can skip the rest of, like, I don't have to read it. Fucking stupid, I already got it. So let's see, and let's just scan. Hold it for 6, then we'll travel 6. Hold for 7, you hold the entire duration, so you travel nothing. Okay. Opinion on Pascal language and its creator, Wirth. I think he's a great computer scientist, worth reading. I mean, well, okay, he's one of the great computer scientists, okay? The creator of Pascal. Now, is it worth reading? That's a different question, because there's tons of great computer scientists, let's say hundreds of them in the past 60, since 1950s, in the past 70 years, there are hundreds of great computer scientists. But is it worth to read them? That's another different question, because there's so many, literature. You can, if you really want to read one guy or his works, like Donald Knuth, Stephen Wolfram, they are all great computer scientists. The latter one is more of a physicist. But anyway, so there are too many of them. Okay, if you count, the inventor of networking protocols, there's thousands of them. Greatest, they are all genius. Or not necessarily genius, but they are great. But is it worth to read them? That's a different question, because they are literally millions of books, on computer science or anything related about programming. So usually, generally speaking, it is not worth your time to read the original writings by these greatest guys. Okay, that comes with the context. So if you are a beginner, if you are, let's say, a college student, a university student, okay, your time is best spent to read textbooks, or Wikipedia. Wikipedia is what I do, or before Wikipedia, it's encyclopedia, because that kind of format allows me to jump to specific topic I don't know, and with links to other articles, so I can precisely read what I want to know. Okay, so anyway, that's another thing. That's about preference, about sources of information. But anyway, so there are millions of books. So if you are a beginning mathematician, if you are still in college, your best time is best spent to primarily read just textbooks or Wikipedia, okay? Because that is a cumulative, condensed, and in a nice format. And all the information came from all the greatest mathematicians or programmers or scientists, in a well-organized format. That is the most efficient source. Read textbooks. Now, if you just do that, of course, that's kind of boring. But, so sometimes, occasionally, you read some of the greatest persons' original writing. For me, for example, when I was younger, that used to be mathematicians, who died 100 years ago. Galois, Newton, Leibniz. Actually, I haven't read them, because when you read the original 100 years ago or 200 years ago, the English also changed, or sometimes they are in Latin or translated version. So the time has changed. So it doesn't really benefit you that greatly. So anyway, so if you are a college student, your primary focus you should be textbooks, but you should occasionally read some of the greatest original writings. So because that gives you kind of the different idea how these people thought originally. Also, you also learn some via context. You also get to understand part of the history of the subject, such as programming or computer languages or computer science. Okay, so Wirth is one of the guy I can recommend. I have not read him though. I know this because I know his name because I'm old. I've been 30 years coding. Let's see, 30 or 20, 30. I've been coding 30 years, so I read. I occasionally run into these people, their work and what they done. So I would say the Pascal inventor is a great guy. Okay. What about programming wiki is not good? Okay, focus on the topic, okay? We're gonna do, advance of code. So, okay, I understand the problem now. Next, since the current record for this race is 9 millimeters, so wait, so what is the record? Okay, so the second row is the record. There are actually 4 different ways you could win. You could hold the button for 2 or 3 or 4 or 5 milliseconds at the start of the race. 2, 3, 4, 5. Let's see, 2. Yeah, so the stupid record holder who don't know mathematics, who is not aware of optimization algorithms. But anyway, so in this second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds and beat the record, a total of 8 different ways to win. In the third race, you could hold the button for 11 seconds and no more than 19 seconds and still beat the record, a total of 9 ways you could win. Oh, okay, so it's not just optimization problem, it's like combinatorial. Among these different ways that you could win, you probably want to select one of them. Let's see. To see how much margin of error you have, determine the number of ways you can beat the record. Okay, you don't just optimize. You find all the possible combinations. So, okay, that beats a number. So to see how much margin of errors you have, determine the number of ways you can beat the record in each race. In this example, if you multiply these values together, you get 288. You get 288. So 4 times 8 times 9, because 4 is the number of ways you can beat the guy for the first race. 8 is the number of ways you can beat the guy. So find the number of ways to beat the record. Then you multiply, you get their product. Another stupidity of advance of code. why do they want the product? This is because why don't they just say give the sequential number of ways 4, 8, 9? That seems simpler. But advanced of code, they want the numbers. Why they want a single number? Because that makes it easier to kind of submit the answer. Like the answer is always just one single number. But again, you have ambiguities. So the solution for this toy input is 4, 8, 9, right? You multiply them together. But what if I made a mistake? My solution is 8, 4, 9. But I multiplied them together, I got the same number, so I also win. Okay, so that's one of the design issue. But the chance of that for the product to be the same number is slim, practically speaking. Okay, anyway, that's about the analysis of this day 6 problem, part 1. Okay, determine the number of ways you could beat the record in each race. Okay, what do you get if you multiply this number? Right, they want the product. Okay, so let's begin. So let's commence. There's only 3 input. Okay, let's commence coding. What? Commence coding. Okay, so the input is kind of like that. So you want first of all, you want to turn this into a list, into a Wolfram language list. Okay, so into whatever your language. So read string. No, not read string. Read string is from a file. So you want split the string input. You want to split by, let's just say by default is split by any white space. Okay. Input 2 equals to, okay, let's try to finish this. At this rate, I'm already 22 minutes, okay? At this rate, I won't finish, but I shall finish it in 2 hours, let's say. I'm not going to, this is interesting because I'm doing this live, so there's a speed issue. So it would be interesting in some of the next videos, I'll do a advance of code where the only goal is to see how fast I can finish a problem, So I don't speak, I don't talk. Like you just start my video and I just talk for 2 minutes to explain what I'm doing. Then it's all quiet. I'm just coding and see how fast, speed coding. Because there are people who will complain. Anyway, so that would be interesting. A variation of the style of coding. So anyway, today I'm just gonna talk. I like to talk, so let's go slowly. So now you got the input. So input is actually kind of the okay, I'm just gonna solve this quickly. So yeah, I'm just do it. You're gonna do it in easy way. Okay, input 2 equals to, so input 3 input. So we're gonna split. So let's split the first one by so we got a list of items. You want to select them only if they are numbers. Okay, let me show you some interesting Wolfram language. So cases. Okay, let's look at the documentation for string cases. What does it do? Magnify, and turn on JavaScript. String cases pattern, give a list of substrings. Okay, that's not what we want. We want Okay, cases which select elements from a list of items. Okay, so cases. So first of all, we split in. We got input 2 is a list of these items. Okay, let's put it here. Okay, okay, so let's put it there. So we got a list of items. Then oh, you run into the window size problem. Okay, anyway, so you see this is let me show you. Tree form at percent means last output. So you see each one of these item is actually a string. So once you got that, then you want, so this is a list, you want to select input 2, and what is the criteria? The criteria is a function, and wait, is it a function or is a pattern? Pattern, okay, so it's a pattern. So okay, pattern, then we say anything where the head of the thing is a, oh god, pattern. Okay, something like this. Okay, let's see if that works. Number form, number. Okay, so I forgot. Let's look at string expressions, which is a alternative to regular expression, number string. Okay, so here you say number string is a pattern. Okay, let's see if that works. Paste, run, empty. So yeah, string. So here is, so the pattern will be okay, string match Q. Yeah, actually I don't want patterns. Okay, so I don't want cases. I think I want select something from a list with a criteria. Here the criteria is a function. So there are two ways to select a sub list. One is select, one is cases. Select takes two arguments. The first one is a list. The second one is a function. Okay, and cases, the second one is a pattern. Actually, you can do both ways, because you can always convert a function to a pattern or pattern to function. But I can show you both ways actually. Actually, I should stick to one approach. Otherwise this video is not gonna end. So let me do the select first. Okay, so select if that argument is a string. So if x is a string, and well, actually not just a string, you also want it to be a number. Okay, god, this is starting to get stuck. Okay, so let me just think about this. So a pattern such that it is a string, and so if you want to do this, so a pattern, it's a string, but also with a condition that, so x, we give a name to the pattern x. Okay, so also with the condition that Okay, so actually this function we can just do that, string match q x, yeah, and okay, so select from input 2 with this function. What this function do is take the argument x. If the x matches that pattern, the number string is a pattern, means it's all numbers. Okay, so if we run that, copy it, let's see. Non-atomic expression expected at position 1 in select. Non-atomic expression. Non-atomic. So what is input 2? Oh, input 2 is not defined. Oh, we didn't. Oh, okay. So we we forgot to define this. Select all. Paste, paste, run. There it is. You see, we got just a purely list of numbers. Now we can also do this with cases. So in these cases, we will just have to do basically the same thing here. Now, if you haven't coded Wolfram language, you probably don't understand what I'm doing, but this should return the same thing, you see. So anyway, so let's comment that out. Let's use a function. So select from this list and with this function, okay? Now that, let's say, input 3, okay? Then all we have to do another thing is to, you see, now this is a flat list. We want to make it so that we want to partition it. Let me just show you. Partition takes 2 arguments, the input, and we want to group it by 3. Let me show you what it means. Oh, we forgot to define input 3. So define input 3. Okay, then partition it. So you see, this is a very different way of doing computation from typical Python, Java, C++. You know, in those languages, you don't pass this input like that. Rather, you first of all split by new line, then you get a line like that. Then you split by white space, okay? Then you got a list of items. Then you drop the first item, okay? Then you got a list of numbers. You know, that's a typical way in other languages, but I'm going into a variety showing you different style. So you split by white spaces, okay? Then you split, you don't even split by new line. You just split by white spaces. So you got a bunch of items like that. Then you use a function to filter out these elements that's not a number string, okay? Then you partition it to this form we want, okay? This is, I would say, least efficient, but it's faster. I mean, faster in the sense, if you are doing prototype, this is faster, okay? Okay, so we got the partition. Let's call this input 4. So we get into a habit of always assign it to a variable, so that way it's easier to see which is what. Then eventually we're gonna merge them, because we don't merge them into one single line. Why double glasses? That's been explained in each of my video, okay? One is nearsightedness, the other one is old man's reading glass, okay? It's been explained in past videos so many times. Opinion on Pascal. What about programming language? Wiki not good. What's your advice? That topic, which programming language to learn, I talked a million times. Go to kasali.info. On top, there's a few videos. Watch them, okay? So by now I have done 500 something videos in the past 3 years. Okay, so anyway, partition gets us that input. So let's concentrate back to the problem. So we got time and distance. So we want to rearrange. So let's do a transpose. Okay, so let me just show you. Why this is interesting. Oh, did you assign it? Not yet. Okay, so you transpose it, so you got this pair. This is more natural for us. So 7, 9. So let's think about the algorithm. How do you solve it? 7, 9. So 7 is the total duration you have, and 9 is the record you want to beat. Okay, so let's think about. So 7 is so you can, the possible ways to, so here is the problem, the combinatorial problem. You want to represent 7 as a sum of two numbers. So 7 equals to 0 plus 7, or 1 plus 6, or 2 plus 5. Okay, 3, 4, 5, 6, 7. Different ways to represent 7 in terms of sum of two numbers. Okay, 5, 4, 3, 2, 1, 0. So there are these ways to represent 7. And so the first column represent how long you hold down the button. Okay. So you partition them like that. I mean, you partition the 7. There's a proper term for that. I think it's called partition of a number. Then you can find all sort of algorithm, partition number theory. Okay, so you see, there it is. In number theory and combinatorics, a partition of a non-negative integer n, also called integer partition, is a way to write n as sum of positive integers. Okay, so in this case, the general case, it doesn't matter how many of them, but in our case, we just want 2. So we want to partition 7 into 2 integers. So anyway, these are the different ways. Then for each one, so there's a result though. So this will equals to, so in general you have a, b, for example. Then you have equal, so the equal will be the final distance traveled. So that means a becomes your speed. Is that true? You hold for 1 second, your speed is 1 second, 1 meter. Okay, if you hold for 2 seconds, giving a speed of 2 millimeters, right? So very simple. So the first column is your speed, basically. Then basically you want speed times speed, a times b. So trivial, so trivial. B is the remaining second, so a times b gets your distance you traveled. Okay, so that, then you want, okay, so a times b, then you want this number to be greater than the given, the given, what is the given record, the given record. Okay, so first of all, okay, so let me explain. Let's explain the problem from a mathematician's point of view. This is how I solve problems. Analyze it to death. Okay, so am I still good? Is this interesting? Is my live show interesting? 8 people watching. Concurrency. Okay, so So you got this. So this is trivial in Wolfram language because there's a function that does this partition. So anyway, so let me write down so people can understand. List all possible partition of the number into two int. Okay. Here's possible partitions, and multiply them, you get the distance traveled. Okay. Okay, so what else? So d, let's say d equals to a times b. Okay, so, let's write this. D is a distance. Okay, so okay, then you want to find such that d distance greater or equal or greater. Let's see. Greater than the record. Okay, record. Then first part, then multiply them all is the answer. Okay. Okay, so now the heart of the problem is to find this partition. In fact, this partition is so simple. You don't need some fancy Wolfram algorithm. You just it's just 1, 2, 3. What the fuck? It's just 1, 2, 3, 4, 5. Okay, let's begin. Let's begin coding the shit. Okay, so now you got input. So now you want to increment. So we can, there's so many ways to do this. One of the ways, if one of the concern is whether you are worried about efficiency. Last time, day 5, we got stunned by efficiency, run out of problem. Because if you are not concerned about efficiency, you can simply generate a list, or the list, just go, or if you are concerned, you don't want an intermediate long list, then you do some kind of loop. You just, it's very easy. Loop and check, so you don't get first of all, generate the entire list. So let's see. So we need to look at get your personal input. Just so simple. Oh, notice big numbers, so you want to be careful. So pop this back, show in browser. So this is today's talk show, and go to the top. And let's say advance of code input. Let's go to my directory and advance of code pass in. Let's copy that, close. Okay, let's make a link. So this is gonna be advance of code day 6 input. Okay, user input. So cut, open, paste, save, close, make a link, make a list, show in browser. There it is, our advance of code user input. Okay. So what's next? Let's have a look at the user input. Is it a humongous fuck? Okay. So 95 to 1000, that's small. So if you're gonna generate the entire list, it's just 1000 items, 2000 items, right? Yeah, so many ways. So in this case, I'm just gonna generate a whole list. I don't care about the shit about your event shit. Okay, pop this back to wait, what? Wait. Oh fuck! Did a dumb bunch of shit. Oh fuck! Make a backup. Okay. Showing browser. Yeah, still good. Still good. Now, pop it out. Okay, back to here. So now we solve the problem. Okay, so let's see. So given a pair, that's duration and record, you want to go through. So the key is these things. So let's try to start to write them out in code. Okay, so the key is kind of like this. If that, return A, right? Something like that. Okay, two numbers. If that is yeah, so so first, well, let's write a function. Okay, x and y. So let's say AB, so it's compatible to our naming, so you don't get confused. Okay, so function AB, let's kind of try to capture this is we have to do this anyway. So this here is a if statement. If AB equals to record, then A, else 0. In this case, else 1, because eventually you're gonna add them all together. So AB, so what is A and B? A and B is what is A and B? Oh, A and B is the partition of that number. So you can do a loop. Let's see. We don't care about speed because the advent of a code, there's no criteria. So we just do whatever, This is one of the things that annoys me about advent of code, because all it cares is a number. So on internet, when you code, so many different languages, people don't really look into about efficiency or not. They only see like this code does this, gives the answer. So if it's shorter or it's dramatic in some way or it's lots of, it's incomprehensible, you get points, right? So if you really care about all kind of issues in this input, like day 5, whether they have identity map or, you are like worry for nothing. You don't get points. Nobody, unless the person dig into exactly how your code works, nobody cares. So this is one of the things that annoys me, because I tend to always come out with the utmost correct and efficient solution. So in this case, since they don't care, let's just brute force brute force the shit out of it. So if we're gonna brute force, let's just let's do some interesting things. Let's look into Wolfram languages number theory facilities. Okay, let's look. There is a partition. Let's use a number theoretical partition function. let's say what is partition partial d. Okay, that's partial differential equation or something. But we want number theory partition of a number. Okay, let's see what is partition. P gives a number Pn of unrestricted partitions of integer. That is like almost what I want. Integer mathematical functions suitable for both symbolic and numerical manipulation. Partition P automatically thread over list. Okay, so partition Pn gives a number Pn of unrestricted partitions of integer. Okay, I'm not sure what it does. Okay, so let's say 7. What? Wait, 7. Oh, okay, so it just, it just give all possible, what? Oh, it gives the number Pn of unrestricted. So there are total of 7 ways, 15 ways to represent 7 as sum of integers, something like that. Okay. Now partitions Q. Oh wait, there I saw an integer partition. Okay, I'm not sure what that is. Let's just explore. Okay, try them out. Let's say, what is this partition Q? Okay, partition Q is 5. Gives a number Qn of partitions of integer n into distinct parts. Okay, in this case, you cannot have repeated, issues. Okay, so but the function we want is integer partition. Okay, the function we want is probably this one. Let's see. Integer partitions n gives a list of all possible ways to partition the integer n into smaller integers. Okay, gives partition into at most. Let's try this. Okay. Integer partitions 7. Okay, let's see. Okay, this is the number of ways you can partition 7. What do you mean, why integer partition? Have you read the problem? Have you been watching? So, or did you just came on? Integer partition is what we want. Okay, so let's give a second argument. That's, wait, what does that mean? Integer partition 2. Okay, so at most 2 elements. So now we want exactly 2 elements. Okay, now so 707 is out, so is 70. So their order, oh, okay, so interesting. So many of these cases are redundant. 0770, they don't count because that's the case for any number. And then you have 1, 2, then the order, does the order count? So if the order doesn't count, so you have 162534, 162534, right? The order doesn't count. Then you have these possible partitions, integer partition of 7. So, and now but the order in our case actually matters. So for each one of them, you have the order matters. Okay, so 6-1 means hold for 6 seconds, and then 1. Let's see, does the order matter? Because ultimately we want to do A times B. So since it's multiplication, the order does not matter. In other words, in mathematicians' jargons, it's called communicative. or community, what is the word, community, multiplication. Anyway, order doesn't matter, okay? So in our case, order doesn't matter either. So once you got the partition, you just multiply each pair. Then if that number is greater than the record, then you return the first part of the pair. Wait. So because this problem, okay, it's a bit tricky because you see the order, let's see again, does it, so for 7, if the duration is 7, you can have hold for 1 millisecond. So it runs for 6 seconds. So you total got 6. Or you can hold for 6 milliseconds. Then your speed is 6, so the result is also 6. So you see, they are the same. So they are the same, but however, the question asks you, so you can hold for 1 millisecond or you can hold for 6 milliseconds. The result distance is the same, okay? Like this 1/6 case, right? But now, you see, it's tricky because now, okay, in that case, the 1/6 pair doesn't count. So, because the solution is 489, the number of ways you can beat the record in each race. So actually, so the order will, even the order doesn't matter, but they will count twice. Okay, so this means if you care about efficiency, there's more ways to save your computation. But anyway, so the solution is 489. So let's see. In the case of 489, wait, how does it? Oh, so the first example, you have 4 possibilities. 4 possibilities. In the first example of 7-second duration, you have 4 possibilities. Why 4? So what is the record? The record is 9, okay. Oh, okay, so 6 times 1 is 6. That's smaller than 9, so it doesn't count. Now 5.2 and 4.3, both them, their product is greater than 9. 5.2 is 10, 4.3 is 12, greater than 9. But however, for each one of them, they count twice because you have the order difference. So the total possible ways to beat the record for the first race is 4 ways. You see, these 2 pairs times 2. So that's why it's 4. You see, it's tricky. So we know the order doesn't matter. So if the order doesn't matter, okay, so wait, so what, so if A times B greater than record, then what do? Then you count it as 2, because 2 ways, otherwise 0. Okay, then you sum this number, it's going to be the total possible ways. Okay, let's comment. Okay, so then you apply this function to a list, to this partition list. So let's copy that. Let's just do an example. Okay, so we don't care about this mathematical thing. So for example, we can integer partition 7, okay, integer partition to 2, then you select, just like we did before, you select you select this list, then your function is this, okay? And the function, wait, you select the list, the function needs to take one argument, okay? You select from a list, okay? Okay, so we kind of need to a nested function actually. So let me just code. So width is the local variable. X equals to X first element, okay? Then B equals to second element, okay? So X is one of these pairs, right? Then you assign them to A and B to break them into two elements. Then if A equals to B is greater than the record, but what is the record? Well, the record came from the current record came from the second part of the input. Okay, so I can let me just hard code it for now so I can show you how this works. So the record is 9 in this first case, okay? So let's do it. Okay, error. So you got some error somewhere. Let's see, what is your problem? Oh, you forgot to copy the whole thing. Nested paren. Empty, that's not correct. So we select out of these and empty, that's not correct. So the function is this function. This function takes a X. Oh, you need to map, wait, select function with A equals B. Why is it empty? Okay. Hi Kasa, hi Frank, hi Hank, Flamio. Why double glasses? Stupid question, you know, that question being answered 1,000 times. Okay, so focus, why is this not working? So A is the first, so X, oh wait, right, you need to return true. Okay, so I know what's going on. So because you need to return true, so you don't even actually, you don't care about what is the actual pair. You only care is that you count the number of them. So you don't want to use select. You want to use count, okay, something like that. Now this is a good time for me to introduce Wolfram language tutorial. You can download it free, just following this link. You get the Wolfram engine, you know, I talked about that many times. So anyway, Wolfram language tutorial, then you got a bunch of my best videos exposition on the Wolfram language. Where's the video? Okay, now it finally showed up. Though, you know, I've done probably 100 tutorial on Wolfram language. Okay, so search for Wolfram language tutorial. Then what we need is about a function that counts the number of elements in a list according to some criteria. Okay, so what is that function name? List operations. Let's see. Position in a list operations. Get parts of list, add elements, delete elements, change elements, check item exist, list order functions, okay, sort and so on, list restructure, list combinatorics, join union different ways, count. So you have join, union, intersection, list combinations, tuples, subsets, that's combinatorial and permutation. List restructure, we have used partition, split by, gather, we want some kind of count, okay. Flatten, that's not what we want. List order, sort, okay, rotate left, okay, check item existence, that's right. Count. Now count, does count by a pattern, okay, they always work by count by pattern. So let's use count then. So instead of select, we should use count, okay. Okay, count takes two arguments. The first is a list. The second is a pattern that determines, okay, so in this case, the pattern is going to be, let's remove this function. The pattern is going to be that A anything, B anything, okay, and with a condition such that A times B greater than 9, okay. Let's try that. Let's just blindly try it. 2, that's correct, because this 5 2 and 4 3. Now once we got that number, we need to multiply it by 2, because 5 2 is one answer that beats the record. 2 5 is also the answer, beats the record. It's because it's symmetric. So we already got a solution. So let's remove that to the code explanation part. Just show some Wolfram language thing. Actually, let's delete that. Anyway, so this count works, okay. So then you just times 2. Space is an implicit multiplication in Wolfram language. Okay, so you just times 2. That gets you the total number of things, okay. Then you do the same for second and the second race. Then you do it again for the third race. Then you got it. Okay, we can try the second. We can try the let's just try right. So the second race is what? 1540. Let's try. 15 is the input and 40 is the number, okay. So paste 8. Correct. Okay. The third one is what? 30 200. Okay, 30. Record 200. Okay. 10. I'm incorrect. What the fuck? Oh, wait. What? The third one is 3200. So I got the number correct. And so why is it? Oh God, we got run into issues. Let's see. Integer partition. Wait, so why is it okay, so the count, let's say cases, okay, 1 2 3 4 5, these 5 items. Oh, identity problem. You see this 15 15, if the two numbers are the same, it only counts as 1. Shit, tricky fuck. Okay, so you got that issue. Okay, so so we want to, what do we want to do? So oh god, this, so we have to do extra check. Now it's getting cold. Okay, so yeah, so there's a case of identity. If the pair of numbers are the same, you don't multiply by 2. Okay, so okay, let's start code. Okay, so you can first of all do an integer partition. Okay, then okay, so you don't want count. Okay, you want cases. Okay, so you want to return all the possible cases. Okay, then once you got all the possible list of pairs, then you want to check if wait, so let's see if I can do a transformation within this function. Yes, you can. Okay, so actually you can do count again. Wait, can you? No, count doesn't allow you that. So you need cases. You need to return all possible cases. So once this is true, you return if A equals to B, you return 1, else you return 2. Okay, so let me show you this. Okay, so we are working on the third column, 30 200. 30 200. Okay, run it. So that's a number. So you add, then you just add them together. Total at percentage. Percentage means the last output. So you got 9. Okay, so does it check? Check. Okay, so here, this is what we want. Okay, so we don't do count anymore. Okay, so far so good. Everything checked out. Okay, so now we just apply this function to the entire thing. Okay. Okay, so we're gonna map this function to let me write in a way so you can understand. Function, this is the body of the function. Then we map. Okay, we map 2 elements. The element input 5 map to this input 5 list, and the first element is a function. Okay, so we map this function, and so the function x, so this 30 will be changed to x. This 200, actually the 30 will be changed to the first part of the input. Okay. Yeah. Then the record will be the second part of the input. Okay, so once you do that, you just got a bunch of lists. Okay, we forgot something. Integer partition. Input 5. Do we have input 5? Yeah, we do. So input 5, so we map it to input. Oh, you forgot. Wait, what did you forget? So map a function, then you X cases. Okay, it should work. So why is the integer partition position 1 of integer partition? 7 must be a rational number. Yeah, why is it not a rational number? I don't get it. So case is integer partition, and here is the second argument. First argument, input 5. Let's see map thread. Okay, let's see. So map thread does parallel map. Okay, so let's call map thread. So let me show you what's going on. Okay, map thread function list. Okay, and the list is going to be input 5. Okay, and what is the function? The function is going to be this function. Okay, but now this function now takes 2 arguments, x and y. Okay, so let's name it something more easier to understand. Duration, record. Okay, so this part is duration, and this part is record. Okay, let's remove the comment. Okay, so I think this is it. Let's see if you get errors or not. Okay, there's some error. So what is the same problem? So function takes 2 arguments, duration and record, and here is the body of a function. Now what does this? Yeah, so the body of function. Okay, let's just, for the sake of debugging, let's make it simple. Let's just do that. Okay, let's just return the argument itself. Right? Okay, very simple. Now, but what is the problem you ran into? Let's see, the function duration records integer partition. What? Okay, let's try to change this function by that. Integer partition 7, 2 must be a rational number. Integer partition 7, 2. What do you mean it must be a rational number? Oh, string. We forgot to turn the string to number. Okay, because our input is now not, you see, our input, it shows like a number, but actually it's a string, because in Wolfram language, it doesn't display the quote. If you want to display the quote, you have to say, if you want to display the quotes, you have to say, my keyboard, you have to say input form, so that shows you the quotes. You see, now you just need to turn that into expression. Two expression. Now those are numbers. For example, I can show you now input form. Those backslashes you see are postfix notation. So if you have F \\G, that means G bracket, then F inside. So it's like Unix pipe, okay? That \\. Okay, so all we have to do is just add two expression here. Okay, so let's try again. There it is. Now percentage sign means the last output. Let's say input form. Let's see, now they are numbers because you don't show the quotes. Okay, so now we got this is the solution. Okay, let's try it again. No. What? What's going on? Duration and record cases. So why is this not input 5? Yeah, input 5. God, what's saying? Empty record. I'm not sure this is. Let's put a condition that makes sure they are integers. No, that's not the problem. So AB greater than record. Let's make sure the precedence is correct. Yeah, the operator precedence. You were right about Golang. Thank you for the advice. Okay, I forgot Charles Scherer. I forgot what conversation was that. Well, you were in XR Discord. So anyway, we got a problem. Let's focus on solving the problem. Oh my God, it's 6, 7, 8. It's almost 1 hour and 30 seconds. I mean, 90 minutes. It's cold. almost done. Okay, almost done. Now I don't get why is this. So here is our function, takes 2 arguments. That's correct. The body of the function is you select all possible cases. But it turns out it returns 0. So why does it return 0? So let's say the duration is 7, right? One of the record. The record is 9. So if you run that, right, so 2 and 2 is 4, right? So in a different case, you have 15 and 40. 15 and 40. 40 is a record. Shift enter. Right, so you got 8. Right, so in the third case of 30 and 200, 30, you got 9, right? So the function here is correct. Did I forget some kind of... So why is the map thread not work? Let's make sure. Let's double check the input 5. Those are numbers, right? So you map thread. Why does it return empty? God, fuck, what's going on? Why is it return empty? Let's debug. What? Oh, you don't want map thread. I know what's wrong, because instead of taking 7, 9, it's actually taking 7 and 15. Fuck. Yeah, idiotic. Fuck. Okay, I understand. I don't know if you guys know what I mean, but for example, our previous code will work. Okay, 489, right? Okay, let's not worry about. Let's just go with that. Okay, so this is very simple. You map a function to a bunch of inputs. Actually, the map thread will work if we don't do the transpose here. So because we did a, let me show you. Okay, we did a transposition. Where is it? Yeah, you see, we basically turned this list into this. So if we don't do that, then we can use map thread. But if we do that, then you want map. Okay, map thread just means a function takes 2 arguments. Then you have 2 lists, each time you take one from each list. That's map thread. Okay. In Python, in Emacs list, you just use map. Map does the same thing. If you have the second argument is more than one list, like 2 or 3, then the function will just like thread them over. But in Wolfram language, you have to use map thread. Because the reason is because map takes a third argument that says levels, like which depth to map to the tree. So anyway, so this is our we've been taking too long, so let's just move on. This is our solution. Okay, so wait, let's just get the solution. So once you get that, what do? You add them together, right? You multiply them together. Okay, so how do you multiply? You can just say times in front. Okay, times add. Let me explain this one. Okay, so in Wolfram language, there's a syntax shortcut when you have fxx, let's say ab. Okay, usually ab. When you have that syntax, that means apply a and to the argument of b. Okay, these two are equivalent, because in Wolfram language, every code you code, before the Wolfram engine does anything, it transforms your syntax to this, always to this nested bracket form. So it's just like Lisp, everything becomes this nested thing. So these two are 100% identical. Wolfram just, before it does any computation, it transforms this into that. Okay, so in this case, we want to multiply. Let me show you how this works. Okay, so in this case, you have the output, that, right? You want to multiply them together. So what do? You can apply the times function to that. Okay, so the shortcut is just times add. Okay, syntactical shortcut. Wolfram language will transform this into that before it does anything. Then it does the computation. Okay, so that's why we are doing that here. So you can look. So let's try. You see, 288. So that's a solution. Okay, so what else? So now we have the whole solution. Let's copy it. The whole solution. Let's new window, paste it here, run it, 288. Okay, now we use the user input. Okay, so the user input is let's put it back, syntax correct, show in browser. So here's today's solution. Okay, now first of all, let's do the user input to make sure that code works. Okay, so back up, pop it out, and now the input is this thing. Okay, slash, okay, so the input equals to read string. Okay, copy all, back here, paste in it, 11600. Okay, are you sure? Yes, I'm sure. Shut the fuck up. Paste there, submit. That's not the right answer. Oh shit. Your answer is too low. What? What's the fuck with the user input? There's some tricky thing again. What? 111,600. I mean 600. Why is it not? Oh God, shit. So the input is interesting because it only have 4 lines. I mean 4 things. So, but by our computation, 1, 2, 3, 4. Wait. So we only got 3 things. Wait, why is that? You see, the input got 4 races, but we only got 3. Let's see. 45, 97, 72. I mean 45. Okay, we got it wrong. 45, 97, 72, and 95 is here. So some numbers got dropped. We don't have 1110. Our parsing is incorrect somewhere. Okay, input 2, input 3, 45, 97, 72, 95, then 305, 1062, 1110. Okay, then input 4 got fucked up. Oh, that's right. Because before we are hard coding. Yeah. So now, so okay, I know what's the problem. So before, we have hard-coded the partition. So we have 3 items because there are 3 rays. So this 3 should be a number of rays. Now in this input, there are 4 races. So, okay, let's do that. Stupid. Let's see. Number of races. Okay, let's just say that. So input, you split by new line. Okay, then takes the first 2, then you split by, then after you do that, you want to split by white space. Okay, then you got the first line, 1, 2, you split by white space, then -1. Then the length, -1. Okay, this is the number of races. Okay, something wrong. Oh yeah, you want to take the first item. No. What? That's right. So then you then you take the length. Oh, okay, what the? Yeah, but why can't you just put the -1 there? Oh, so you see, this, we run into an operator precedence issue. So this -1, they connect, that's why. So you need a paren if you want to do it that way, that. So that is your, okay, I don't want to use the backslash notation. It's the same anyway. So the number of races is this number, okay? So then you put that here, partition to number of races. Okay, there are easier ways, but let's just get on. Okay, select all, paste, run. 40. Wait, this is not right again. So let's see. Partition. What? Why do we partition 3 before? Yeah, okay, let's, so three. Hello from Brazil. Hello, Marcos. Partition. So we want to partition, right? So input 4. Right. We got the number of races wrong again. What's going on? True. Oh, we forgot. I forgot to take the first item. Yeah, okay. So now let's do it again. Input string and our function, copy it, paste. Yeah, there it is. Yeah, I'm sure it's correct, you idiotic crap. That's the right answer, of course. Okay, solve the problem. Thank you guys for watching. This is fun 100 minutes. Smooth sailing. We didn't get stuck anywhere, but we just went through a lot of explanations on how this code works. Okay, now let's pop back. Let's pop back. Let me show you. Okay, so basically that's it for today. We got a solution. Now the solution is like, this number of lines, but you can combine it tremendously. So now let's do that. Okay, let's see the people here watching. Are you guys watching? How many people? fantastic. So we finished, we solved the problem. We can go on to part 2, but no, let's do that another day, okay? Part 2 another day. That will be better. And okay, sponsorship time. If you like my stuff, go check out my website and let me show you what you can buy. You can, of course, you can just donate to me, Patreon me, okay? Amazon gift card or PayPal, okay? Right on the Xa Talk Show page. Or if you want something in return besides my talking Xa Talk Show, you can buy my Emacs tutorial. This is comprehensive, well, it's the best tutorial for Emacs and Emacs Lisp. Okay, I've done like over 100, 200 videos of Emacs Lisp coding in past 2 years. Okay, Emacs Lisp, the best tutorial. Okay, so you can click that and go through my Emacs tutorial. Then there is buy Xa Emacs tutorial. Okay, I can read it online. Why should I pay? Why should I pay? Because you are beautiful. Okay. Okay, that's Emacs tutorial. And another one of best thing I'm proud of is my JavaScript in depth. JavaScript is a very complicated language, okay? And I have the most comprehensive, I would claim, the most in-depth and comprehensive and easy, the most extreme easy and concrete and correct tutorial by example of the in English, okay? In English on Earth. Okay, my JavaScript tutorial on Earth, my JavaScript in depth, okay? It's better than Mozilla, for example. Mozilla JavaScript tutorial actually sucks. And I would say there are possibly 2 JavaScript books that is possibly better than mine, depending on your taste of the style of the tutorial. There's so many styles of writing and many styles of organization of programming language tutorial, different styles of explanation. So I would say in this Earth, there are possibly 2 JavaScript tutorial that is you might consider better than mine. One is one by Douglas Crawford, the guy who invented JSON. Okay, he's a great guy. One of you guys asked me, is it worthwhile to study Wirth? Wirth has been dead for like 10, 20 years. Pascal, the creator of Pascal, that's several generations ago. So if you want to read someone who is still alive, I can recommend Douglas Crawford. He still does a lot of videos on JavaScript. He's very old now. He's 60 something or 70. He's like, I'm getting old myself. So Douglas Crawford, I've read quite a lot of his stuff. So anyway, he has written a book about 4 years ago, okay? The latest, of course, he wrote previously JavaScript, the good parts. Okay, digression time. JavaScript, the good parts. So he has written a new book. Okay, I mean his video, JavaScript better parts, is very good. Okay, that's someone who is a great programmer. I would classify him as a great programmer as opposed to computer scientist. They are different. But he's a great programmer, but also is a great programming language expert. Okay. But anyway, he has written a book, and search just search the web. Okay, so let me try to find the book. Okay, JavaScript book review 2023. There it is. So there's my book. There is these are old JavaScript, the good parts by Douglas Crawford, like 15 years ago, and JavaScript by this is also fantastic definitive guide by the Rhino book by this guy whose name is David Flanagan. That guy I also highly respect. So Douglas Crawford and David Flanagan. David Flanagan is into writing programming language tutorials. Okay, I'm telling you my opinion. I'm going to claim this is the best opinion on programming language books, because typically for Zoomers, you don't know which one is a good book. You go to online, there's lots of grifters. Okay, they're gonna tell you, oh, this is the best book. That is, oh, JavaScript Ninja. They all have opinions, blah, blah, blah. But they don't know shit. Okay, this Zoomer generation or late millennial, they don't know shit. Okay, the best JavaScript book is Rhino book. Okay, this is a new version. About 3-4 years ago even. So previously is 15 years ago, but there's a new version. Okay, by David Flanagan. That's one of them, possibly better than my JavaScript in depth. Then the Douglas Crawford, okay, 2018, how JavaScript works. I highly recommend that. Okay, so this is another book. This one is not too thick. Okay, so it doesn't really cover lots of things. It doesn't cover the entire JavaScript product, the library, and it's thing. It's more like telling you how JavaScript is designed. Okay, anyway, I highly recommend it. Then this one is also someone I highly respect, Dr. Axel Rashmeyer. Okay, he's written a series of JavaScript books, exploring JES6 and so on. You go to his website, you'll see. But he has one book for the latest, because JavaScript every year there's a new version. So he started to have so many, deep JavaScript theory and techniques, tackling JavaScript, upgrading from JavaScript. Oh, tackling TypeScript, shell scripting with Node.js. He's got several. Speaking JavaScript, ES1 to ES5. Okay. Anyway, this guy, his JavaScript is also the best. Okay, but his style is more like very technical and dry, very extremely technical and dry. Okay. And often go into a depth that you can be bothered to know. Even if you are a Google, you are a Googler programming web front end for like, let's say 2 years, you are an idiot. Okay, you don't know JavaScript. But anyway, so so he goes into a lot of depth, that like so much detail that you almost like you'll never find it useful. Something like that. Okay, so this guy, so I can recommend the Exploring ES6. That's a EDR jargon. That's a nickname for JavaScript 2015 something. Yeah, anyway, and then there's ECMAScript. Another name, stupid, but anyway, it's just JavaScript. Okay, so this guy, Dr. Axel Rashmeyer. Okay, I can recommend his stuff. So in summary, actually in summary, check out my article. Go read it in depth. JavaScript Books Review 2023. Okay. So that one, and then there's this one. Okay, SICP, Structure and Interpretation of Computer Programming in JavaScript. Okay, this new version. Then this Eloquent JavaScript, I do not recommend at all. Okay, this Eloquent, this Eloquent JavaScript is for beginner. Now this guy is an expert. Okay, I can tell you he's a JavaScript expert. But however, his book, this particular book, Eloquent JavaScript, is a idiotic Verbose book, JavaScript book for JavaScript beginners, and it's also for JavaScript, and you know, for like almost like you never programmed before, okay? And also it's in a style that's elaborate, telling a story. Like he's gonna, once upon a time, he's gonna say, once upon a time there's a JavaScript and my experience something something, and I run into this mountain and I found this trail, and this is, and I feel that this is analogous to this JavaScript function. The fucking idiotic fuck. Okay, eloquent JavaScript. And then I give you my analysis about Mozilla. Mozilla, their JavaScript tutorial is shit. Okay, it's misleading shit. You read it, you get you code in a bad way, you run into problems. Okay, Mozilla's JavaScript tutorial. Now, mark exactly what I said. Okay, Mozilla's JavaScript tutorial. There's tons of things on Mozilla, the Firefox thing, you know. So, but they have one section called JavaScript tutorial that is teaching you JavaScript. That part is not good, okay? However, Mozilla is excellent. In fact, nowhere else on earth you will find alternative is that the Mozilla's coverage of the latest bleeding edge JavaScript stuff. Okay, for example, DOM. Or can you use some new, JavaScript coupling with CSS, latest CSS, that's still experimental, or some JavaScript, the latest development, which browser, for example, JavaScript, every year there's a new version. So you want to know, can I use this function in this, which browser supported, and things like that. And sometimes the function's behavior is not finalized yet, those kind of thing. Latest bleeding edge. Mozilla is the best source. And in fact, there's no other source, no other books, no nothing. Okay, so if you are a professional web dev JavaScript, of course, you need to use Mozilla. You have to. There's nowhere else. The W3 school is the most idiotic, and tutorial point and Java point, those are Pajit. Those are idiots. They're for beginners. Okay, they become the most popular. Anyway, so that's my summary of JavaScript books. So you can buy as a donation. You can read them online, of course, but as a donation, you can pay me, and you get I give you a download, so you can read offline wherever you go. It's HTML. Okay, it's HTML. It's not PDF. It's not ebook. Okay, it's plain HTML, so you can run in any browser. You'll have a hard time if you try to run it on a phone. I think you need to translate or something. I haven't done that. Anyway, so that's some of the summaries of my books. Well, yeah, kind of. You can buy. Okay, so that's it for today. Thank you guys for watching. Bye guys. Oh yeah, we forgot to do the second part too. For the shortest code. Shall we do it? Yeah, I can do it in 10 minutes. Well, but I started to talk about JavaScript. Is it still worth the time? It's 2 hours already. So WH says, I'm a Vim user and I got very high one day and wanted to know what the life of an Emacs user is like. I found you by accident through that ordeal, and I love your content. Thank you very much. WH. Okay. Yeah, so right now, should we condense the code? Nah, let's not. Where's the code? I can make this code in one line. Actually, I can do it quickly. Let's do it, okay? So let me do it. Yeah, so first of all, copy, okay? Let's make the code in the shortest number of line. in one line. So let me concentrate. Input 2, input 3, okay. So string input, so you want to number of races, so let's actually rewrite the whole thing. So string input, so first of all, split by a new line. So we split by a new line. Let's not define that. We split by a new line. Then okay, so for each line we split again by white space. Okay, then what do you do? Each time we split again by white space, then okay, then you select okay, so let me actually, I need to try this out. Yeah, so then you no. So now you got that, and then you so right now we care about shortest, so let's just write things my way. Okay, so let's not string split. Okay, so actually you just need that, don't need that. Okay, okay, so now you split that. Then what is the next thing? You want to select. So you want to select on cases. Okay, we can do select. So cases, this is your number, and you want the pattern, anything. So cases, anything with a condition that string match X is number string. Okay, so let's try that. No, something wrong. Okay, so cases anything. So cases anything. Cases take two arguments. Cases string match Q X number string. So Y is not image. Oh, default case is level spec 1. Yeah, so we want level spec 2. That's what we want. So once you got that, then what? Then you want to partition. Actually, how do you partition? You want to know the length. Okay, count. So now we need to make sure there's no extra lines. Okay, it's stupid. I mean, there's no extra line return character. So now we can count. So count pattern. Okay, so count input. We want to count the number of lines. Okay, so string count. So actually not count, string count. We want to count the number of new line chart. So that tells us how many okay, so we need to reread this input because we just modified it. Oh, now it's just 1. Right, okay, so string count plus 1, okay, plus 1. So that is a number race, okay, so that is actually the number race. So what is this? Don't need that, don't need that. The number of race, you don't need that. Here, the number of race is actually, you need to put that here. Okay, so wait. That's good. Now partition. You want to partition. Let's see. Can you have it in a functional form? At least no, you cannot. I mean, you cannot have it in a queried form. Okay, so you have to use the partition. So the partition here is just this. Okay, then yeah. Yeah, that's what we want. 1, 2, 3, 1, 2, 3, 4. Yeah, because there are 4 races. Yeah, and here we transpose. Actually, you don't need to transpose. And 2 expression. Okay, 2 expression at transpose. Okay, you can do it either way. So okay. Okay, so this part now is just here. Okay, so that is our solution. One single line solution. Okay, wait, that's wrong. That's wrong. What was the answer before? Forgot what's the answer. Yeah, fuck. We got the answer somewhere. But now it's hard to debug. Now you what? Wait. Okay, something is wrong there. Did we forgot to transpose? We did. Oh, so you don't even need to. Don't need to partition, okay? Actually, you kind of need to. So string split input. Yeah. Actually, let's just apply a function, okay? And the function is going to drop the first item. Okay. That's what we want. So then we do a transpose actually. You've got actually you don't need transpose. Okay, so we are simplifying a lot of our code. We are simplifying a lot of our code. So now you use map thread instead. So the first part is okay, so this function and in this function it takes 2 arguments. Okay, so this will just be 1, this will just be 2. Simplified so much. Okay, some error, no worry, we'll figure it out. So first of all, that's right, so you map thread and okay, you map thread, you forget about total. Oh, we forgot to change it to expression. Oh yeah, there it is, expression, that's why. That's right. That seems right. So do we need to times, right? We need to times them together. Easy. What was the answer? I forgot. What was the correct answer before? Let's see. Do we? I think 2612736. Yep, that's the correct answer. Copy it. Let's put the correct answer here. Okay, so you don't need this. Let's see, map thread correct. We fantastic, one single line solution. Okay, this is the thing. Okay, paste it here, there it is. Okay, so fantastic. Now we can copy the Wolfram language here and paste it back here, so it kind of shows you kind of like nice format. I'm not sure it's nicer, but let's do it my way. Okay, so here is the solution. HTML color it, there it is. Now the shortest solution is here. Okay, so now let's put it here, shortest solution, and annotate nicely. Advent of code 2003 day 6. Okay, shortest solution on earth. Now I can still make it shorter than though. So how do you do? Yeah, let's not worry about that. But anyway, so copy that, put it back, and this. Part 1, okay. Okay, that's complete. This is the solution, shortest code. And here is more explanation kind of approach. Bye guys.